Approximating probability. In this lesson, we're going to look at experimental probability and theoretical probability. So experimental probability is something that you observe. It's something where you actually do it. You do an experiment and you count the number of outcomes for one result or another, right? Theoretical probability is the probability that's calculated mathematically. For example, the chance that a coin will land on heads. If you flip a coin, there are only two possibilities, right? It's either going to land on heads or tails. So you have a 50% chance that it's going to land on heads and a 50% chance that it's going to land on tails. So if I were to flip a coin, say 100 times, the theoretical probability tells me that the coin should land on heads 50 times and tails 50 times. But we know that that's probably not always the case. If you flip a coin 100 times, that you're going to get exactly 50 heads and exactly 50 tails. So that's the difference, right? Theoretical probability says it's 50%. Experimental probability, it's probably going to be close to that, but not exactly that amount. So let's try it. I happen to have, well, I don't have a coin nearby, but I do have a guitar pick. So I'm going to take this pick and I'm going to toss it. I'll show it to you once and then I'm just going to pause and I'll fill in the rest. So let me go get my pen out. So I'm going to take this pick and I'm going to toss it and I'm going to record what it lands on, right? So I'm going to throw it, caught it, and I'm going to put it on my hand. This one landed like that. So it landed, let's call this tails, because on the other side there's a design, right? So it landed on tails. So with throw number 1, I'm going to put a T. I'll show you one more. I got another tails. So that's going to be another T. I'm going to repeat this. I'm going to do it 30 times, and then I'll come back and I'll share the results. All right, all done. I threw my guitar pick 30 times, and I recorded the results. And for a while there, I was like, oh my gosh, how many heads in a row am I going to get, or how many tails in a row? You would think it would alternate and go back and forth, but that's the way experimental probability works, right? So our prediction is that out of 30 times that I would probably get 15 heads and 15 tails, right? That's our prediction. My prediction is that I would get heads 50% of the time. So let's see what actually happens. So in this table, I'm going to be recording the relative frequency, right? Relative frequency is the number of tails, in this case tails. I should have asked what's the probability of getting tails, but it's the same, right? So what is the number of tails out of the number of throws? Okay, so let's look at the first 5 throws. In the first 5 throws, so that goes up to here, I got tails 2 times out of 5. So my relative frequency is, I got 2, right, out of 5 throws. So my relative frequency is 2/5. And if I write that as a decimal, that would be 4/10, right? Double the top and bottom, which is 0.4. All right, let's do it out of 10 throws. So out of 10 throws, that would take me to here. Out of 10 throws, I got, let me get a different color for you guys. I got, I got 1, 2, 3, 4 tails out of 10 throws. So for 10 throws, I got 4. So again, that's 4 out of 10 still keeps me at a 0.4. for my relative frequency, or I could just write 4/10, right? 4 out of 10. All right, so now 15 throws. So now I'm going to go a little farther. So now I'm going to go to here, right? So when I go to that point, now I'm counting my number of tails again, right? So my number of tails is 1, 2, 3, 4, 5, 6. All right, so now I've got 6 tails. So 6 out of 15, let's see what that is as a decimal. That's not one that's as easy to do in my head. 6 divided by 15. Oh, look at that. It's 0.4. Oh, of course it is, because it's this fraction times 3. Okay, so now we go to 20 throws. So I'm going to add 2 more tails. And this should say, by the way, this should be tails. Okay, so I'm going to add 2 more tails. So now I have 8 tails, and 8 out of 20 is, oh my gosh, it's still 0.4, because it's the first fraction times 4. It's staying very consistent. All right, let's look at 25 throws. So now I'm going to here. Oh, and now I get a bunch of tails, right? So now I have 1, 2, 3, 4 more tails that I'm going to add on. So that's going to give me 12 out of 25. So 12 out of 25, that would be what out of 100? Think about that. 48 out of 100 multiplied by 4 on the top and bottom. So that would be 48 hundredths. All right. And then finally, I've got 1, 2, 3 more tails. So now I've got 15. Oh my gosh, that almost never happens, that it's right on the money. So I got 15 out of 30 throws, and I did reach that magical 0.5 that I was looking for, because that's what I expected it to be based on the theoretical probability, but the experimental probability doesn't always come out that way. I got kind of lucky, I guess you could say. But I could have gotten 14, or I could have gotten 16, or I could have gotten 17 or 13, something kind of close to 15. It doesn't always come out to exactly what you think it's supposed to be. But what does happen is the more trials you do, the closer the experimental probability will get to the theoretical probability. If I were to perform this experiment 100 times, if I were to flip that guitar pick 100 times, I would get a little closer. If I were to do it 1,000 times or 10,000 times, then I would get really, really close to 0.5. As the number of flips increases, or the number of throws gets larger and larger, the closer my experimental probability will get to my theoretical probability. Okay, so let's graph it. So here I've got a dot plot, right? So this is 0.5, right? So that means that this is 0.1, 0.2, 0.3, 0.4. Now for us, it stayed on 0.4 for quite a long time, right? And then it went up to 0.45, so that would be right about here. And then it went up to 0.5, and that's kind of where we expected it to be, right? It kind of stayed at 0.4 for a while, then it got a little closer to 1/2, and then it was right at 1/2 at the end. Okay, so theoretical probability is the mathematical calculated probability. Experimental probability is what actually happens. We can make predictions based on theoretical probability. So let's say, let me give you an example. Let's say you want to try to predict the number of times that this spinner would land on blue. Assuming it had a spinner, it doesn't even have an arrow. Let's assume it had a spinner on there and you were going to flick and spin that, right? How would you predict the number of times it would land on blue if you were going to spin it 28 times? Well, we saw in the previous lesson that the probability of this spinner landing on blue is 2 out of 8. which is a fourth. You can keep it in fraction form if you like, or you can convert it to maybe a fraction that has a denominator of 100, right? So 4 times 25 is 100. So 1 times 25 would be 25. Or you can write it in decimal form, or you can write it in percent form, whichever you prefer. But for this next step, we're going to want to have it either in fraction or decimal form, because now we're going to do some calculations with this probability. So like I said, if I spin this spinner 28 times, how many times will it land on blue? Well, I know that it's supposed to land on blue 1/4 of the time, right? So I could multiply 28, and I'm going to make it over 1 because I'm multiplying by a fraction. So I like them both to be fractions. So 28 times the probability of it landing on blue. I can do a little bit of cross-canceling here, right? Because 4 goes into 28. So divide by 4, divide by 4, and I get that my answer would be 7 times. So my prediction would be that if I spin this 28 times, 7 of those times it's going to land on blue. That's using theoretical probability. That's making a prediction. Is it definitely every time you do it 28 times going to land on blue 7 times? No. But the more trials you do, the closer that probability of it landing on blue is going to get to 0.25 or 1/4. You could also do this if fractions aren't your thing and you'd rather use decimals, then you can also do this by doing 28 times the decimal of the theoretical probability, right? Decimal form. So 28 times 0.25, still 7. But for those of you that want to deal with fractions as little as possible, there's your method. So 2 out of 8 times, or 2 out of 8 spaces are blue. We reduce that to 1/4. You can do 1 divided by 4 on the calculator to get 0.25, and we multiply that by the number of trials to predict the outcome before we do the actual experiment.